Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning to everyone. Today I would like to talk, Today I would like to presenting to all of you about my article review that I have been summarized just now. For the topic water chemistry 50 years of change and progress. Okay, let's go to article citation. It was written by Patrick L. Brezonic and William A. Arnold from the Department of Civil Engineering, University of Minnesota 500 Westbury Drive, Southeast Minneapolis, Minnesota 55455, United States. For the research objective, its analysis the 50-year journey of modern water chemistry, which is since 1960, by reflecting on its evolution as a distinct scientific field. The question I have already two questions, which is for the first one, how did water chemistry emerge as its own scientific discipline from roots, and what future scientific opportunities and social the needs should water chemistry focus next? Okay, methodology of approach by the article by time tracking, tracing development from the late 19th centuries to the present, pulling in milestone from limnology, chemical oceanography, geochemistry, and sanitary or environmental engineering, and is also comparative analysis definition then versus now water chemistry and focus on problems. Okay, for the key findings, for the first one, water chemistry emerged as a distinct field in the late 1950s to early 1960s, evolving from disciplines like limnology, oceanography, geochemistry, and sanitary engineering. For the second one, key features like Venus stump and G. Flatley helped establish the field by emphasizing physical-chemical principles such as thermodynamic and kinetic, and a multidisciplinary approach. Lastly, technological advances such as improved instrumentation and computer modeling revolutionized how water chemists analyze and understand aquatic systems. Let's go deeper. For introduction, this review article are focusing about the composition of natural water and the sustainability for human use. Here we examine the origin of water and describe how the field are developed by times, which is environmental era, by focusing in several related of discipline. For the first one, origin of water chemistry. Alright. For over 50 years, many scientists have tried to analyze the chemistry in water. These scientists came from many fields, but it's always been a sidekick to main research. Now, water chemistry has become the star on its own to the research. It's dedicated to know and understand what's in water and how those substances make changes and interact. This thing is sparked by the rise of environmental engineering, which a field that needed a deeper scientific knowledge to tackle pollution and shape policy. For the second unit, what is its name? For a very long time, people used the name water chemistry in a formal way. It was a it was an official subject of study. It's changed in 1962. The synonymous term aquatic chemistry was later coined by Werner Stamm in the mid 1960s to blend studies of natural and engineered water system. Today, the names are used interchangeably in the field, and they mean the same thing, and people in the field use them interchangeably. It's not wrong to use one or the other. For third unit, water chemistry courses and textbooks. When people first studied water chemistry in the 1960s, they focused on simple non-living chemical. Without computers, they had to solve problems using a long math equation on paper. They mostly are not man-made pollution and how fast reaction occur. The field became a proper science in 1970 when two scientists wrote the first major rule book for it. After that, other textbook were written to make it easier to learn. However, these new books mostly stuck to the old topics and didn't include new important ideas like man-made pollution from pesticides and or plastic. Because of this, pollution is now taught as a separate, specialized subject instead of being a part of a basic water chemistry course. Next, how has water chemistry changed over the past 50 years? In the last 50 years, three main things push water chemistry forward. For the first one, new problem. Second, better technology. And third one is new ideas. For the first one, real world issues like polluted lakes, acid rain, and chemical from farms and factories force scientists to find solutions. Eh? Major pollution concerns like eutrophication, acid rain, mercury, and organic contaminants. Okay, direct research to understanding their fate and effects. And second one, better technology. New, powerful machines can now detect even the tiniest amount of pollution. Superfast computer can also do complex complication instantly, allowing scientists to predict how water will change. For third one, new ideas. Scientists made exciting discoveries like how sunlight change water chemicals and how pollution sticks to the surface. These new ideas completely change how we understand water. The chemical process in water completely changes. For the next, okay, constant depths in the field. We divide into the four sector. So the first sector is a goal its goal is the same, which is to provide clean drinking water to, and keep our environment healthy. Second, it still works with other science like biology and engineering to solve problems. Third, it studies all water, formation and lakes to the water in our pipes. Four, it's always used new tools from other fields to find better answer. Even today, scientists are still trying to solve the same basic puzzle they start with, the algae problem, metals in water, and what water look brown. Okay? For me, weakness of the article is the first one can be too detailed for beginners. But the main idea is the simple. The article includes many complex chemical terms like speciation, kinetic, surface complexation that might be confusing for someone without a science background. Second, is focused on names and events. The article spent a lot of time talking about specific people, university, program, and journal names. This is interesting for experts, but might be less exciting for a general reader. For overall, briefly, this article is a very well made history lesson. It is excellent for understanding how the science of water quality evolved and why it's so important. However, because it's detailed and uses scientific language, it's best for students or people who are already a little curious about science. It's less suitable for someone looking at a very short, simple summary without any technical terms. That's all from me. Thank you.